one that you haven't seen before. This is 1 over x squared. So what's going to happen here is we're doing 1 over x, but then what do we do with those values? Square them. So if you look back at our picture here, we had our ninja star. What's going to happen on the right to all of these values here? What's 1 squared? 1. What's 2 squared? So this point will be moved up to 4. What is, right here, what I have 4. 4 squared is 16. Now here's a tricky one. What's 1/2 squared? 1/2 times 1/2 is 1/4. So this is going to make it so these ones are going up faster and these ones come down faster. So that's what squaring this is going to do. But what about right here? Why is it going to flip it to the top, Caitlin? There you go, because we're squaring it. So here I'm going to take negative 1/2 and square it, and that will become positive 1/4. So what's going to happen is it's going to be coming up together like that. So let's actually do some key points here, okay? So when I do 1, 1 squared is 1, and then I'm going to do 1 over 1, so that'll give me just that point. Same with negative 1. Negative 1 squared is 1, 1 over 1 is 1. So these are your two main key points. But let's also do 2. 2 squared is 4. So at 2 we're going to be 1 over 4, so that'll be about right there. That'll be the same with negative 2. And then let's do 1/2. 1/2 squared is 1/4. And when I do 1 over 1/4, what is that going to do? Remember, when you divide by a fraction, you multiply by the reciprocal. So this is just 4. So at 1/2, we're going to be at 4. And at negative 1/2 will also be at 4. Oops, that was not pretty. So 1 over x, it looked like what I would call a ninja star. This one I call a volcano. Because if you can just imagine, this is the top of a volcano and then smoke billowing out, right? This is your volcano. Your key features will be very similar. I'm going to let you finish filling those out on your own. Alright, so these are our main main parent functions. Is this something that if next time I gave you a blank graph, could you fill those in? Great. When do we get out of here? When? 11:04? Okay. Some people are like packing up. I'm like, wait a minute. We're still good, right? Oh, GTI is the worst. GTI, you're going to get to where we're starting 1.3, but we're not getting super far, but still come pick these up as you go. So, GTIs, grab one up here, and one up here. Alright, so for those non-GTIers, we're going to finish doing this, and then we'll take a little break, okay? Then we'll get started on 1.3 and get as far as we can. So, what we're going to do now is we're going to talk about piecewise functions. Piecewise functions are just functions that are using different functions combined together. So let's actually start with a real life application here. I'm going to have Emily read this for us.
Just the first sentence.
Yeah.
The height, age, in feet of a model rocket above the ground t seconds after liftoff is given by.
That. So what are we talking about here? Height of a rocket. Have you ever launched a rocket? It's pretty fun, right? But now, how come we restricted the domain? What shape is this going to look like when you graph it? Well, let's think. Yeah, so t squared, if it's squared, what shape does that make? That's a U. Sorry, it's kind of awkward to have this holding, but it makes a U, right? And then what happens when you times that by a negative? It makes that, well, parabolas, right? That's what happens with the rocket. It's going to go and fall down. Now, how come we're restricting the domain? How come we're just saying it's like that from here to here? Well, what's it going to be after 20 seconds? Is it it's going to start on the ground. It's going to launch in the air, fall and hit the ground, and then what? And it stays on the ground, right? Until the kid picks it up. So now, this has two different functions, and if we're trying to figure out the height of the rocket, we have to know which one to plug it in. For example, 10 seconds. Would that go in this first one or in the second one? First one, because between 0 and 20 goes in here. So I would plug in 10, and it would tell me my height. We could actually, I guess we could figure that out real quick. 10 squared. So we're going to have negative 5 times 10 squared. 10 squared is 100, so that's negative 500. Plus 100 times 10 is 1,000, right? So I think that's 500. So 10 seconds in, it's going to be 500 feet in the air. Now, what about 60 seconds? That's a minute afterwards. If I plugged it in here, it would give me a very negative number. It'd be all the way down here. But is the rocket going to be down inside the Earth? No, so I'm going to plug it in here. If it's greater than 20, then it's going to be 0. All right. Does that make sense how we got these two, 500 and 0? This is just kind of an introduction to a piecewise function. We'll have different pieces that we put together to make a function. Now, as far as number 2, it says, when will the height be 375? So in this one, we're not plugging in, we're setting it equal. Which of these are we going to use to set it equal to? The top one, because is the bottom one ever going to be 375? No, 375 is going to be probably somewhere like right here. So let's say that's 375. We're saying, hey, after how many seconds is that 375? So what we would do is then we'd set negative 5t squared plus 100t. We would set that equal to 375. From there, we'd get it all on one side. We would like factor, set it, and solve from there using a quadratic formula. I'm not going to do that right now. You know how to do that, right? If you don't, come get help. So that's a general idea. Main focus here is piecewise functions. You feel okay? We've got one more and we'll take a break, all right? Yeah, it's just this one, right? Okay, sketch a graph of this one. So we've got 3 things going on. We've got x squared. Show me with your hands, what does x squared look like? Great, but when are we using this? When x is less than or equal to 1. So we're only using kind of this part over here. We're going to be 3 if we're between 1 and 2. What does 3 look like? Show me with your hands. 3 is constant, right? And what does x look like? Show me. That one, but that's only if x is greater than 2. So what you're going to do is kind of put all those together and make a weird looking graph. I want you to try that on your own. Give you a head start here. Good luck. We're gonna start with x squared. But when are we seeing x squared? Good, now that less than or equal is important because that means at 1, we are this one, right? This is our one. So we're gonna, what is the value of x squared at 1? 1. Okay, so that's good. There will be change. I'm gonna do x squared in, come on now. In red. Okay. So you said it's at when 1 is 1. What about at 0? Negative 1. Negative 1. What's negative 1 squared? Positive 1. What's negative 2 squared? Alright, so what we have here, this is x squared, but we're only using this when x is less than 1. So what I did was I kind of drew these, we're having a change here at 1, we're having a change at 2, and we'll kind of go from there. Alright, great, so then Michaela, after that, what's going on next? 3. And for which x values do we see that? Great, so we're gonna, since this has a line under it, let's put a solid dot, like that. Well, what are we going to see as we get to 1? Yeah, an open circle because we're not including that there, right? Because remember, a function, I can only have one x value here. So basically, we're x squared, and then at 1, we're still x squared, but right after that, we jump up to this, all the way to 2, and then lastly, what are we going to see at when x is greater than 2? Just x, which is a diagonal line, because I want to do that good. That's our identity function, so when x is 2, we're going to be at 2 as well. Whatever you plug in, it's the same. It'll be an open circle, and then when x is 3, it will be 3. When x is 4, it will be 4, so it's just this line like that. So the point is we're taking our parent functions, but we're just doing pieces of them and putting it together. This is what we call a piecewise function. Okay. How do you feel about that? Are you okay? It's a little weird, but with practice you'll be fine. And I think we did some practice with this for the homework. If you want to see a good looking picture, that's what it should look like. Isn't that basically what we did? Alright. Okay, we're going to take a 2-minute breather, okay? We're going to start the next section in 2 minutes, but for now just take 2 minutes to kind of decompress